Okay, the last part is you can turn to chapter 4. The chapter 4, we just put some small part, test for convergence. What does it mean for converge? Converge is that the sum is finite. It's a finite number, okay? So which is the converge. And then if it is diverge, diverge means the sum will tend to infinity. Okay, so some of what? Maybe some of the sequence， 即係一堆數加埋，如果係個有限數，即係 converge 啦。And then some of the sequence. Okay, if it is infinite, then it will be diverge. Okay, so the focusing part is very small. I just talked about just some minor point. Okay, say for example, like if we have the number, if it tends to 0 when a k tends to infinity, given that the sequence is like a1 plus a2 plus a lot of ak where there is infinity numbers add up when the sequence, if it is zeros, and then that means we do not add anything at the back. Okay, so that's why we will get the answers to be converged. Okay, if it is not 0, so then it will be converged. If the sk, the sum of the sequence converge, we have the ak must be 0. Okay, so what is the meaning of it? You can just reviews about like the question 1. So say for example, like the what we have about in chapter 2, limit when k tends to infinity, especially if you see this 1k equals 0, sum up to k equals to infinity, but the original is like 2, 0 plus 1, 0 plus 2, 1 plus 1, numerator is 1 plus dot 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 until here is infinity, the k is infinity, 2 times k infinity plus 1. So the original stuff is like this one. Okay, so if we would like to know the limit, okay, so you notice that you have the k over k, 2k over k plus 1 over k, right? So both sides should divide by k, and then the answer is like the answer is 1 over 2, which is taught in the chapter 2 already. Okay, so this is 1, this is 2, cancel out, this is 2, and then this is 0. So 1 over 2 plus 0, so the answer is 1 over 2, which is not 0. So the sequence is divergence. Okay, so once again, the correct answer is if you got something which is 0, so then you will have convergence. If it's just like these questions, we have 1 over 2, which is not 0, so then you will got the sum of the sequence to be divergence. Okay, and then one of the case number, well, this is case 1. Okay, we have exactly similar questions which will be asked, and then summation k equals 0, summation, and then some simply just test about this part to be the ak, which is the general numbers. Okay, and then the last is we have the following geometric series. Okay, geometric series, the very last part for chapter 4. Some of the sequences, in fact, in terms of sequence. Okay, so say for example, like 2 over 3, 4 over 3, 8 over 3, each of the numbers is multiplied by 2, right? Okay, so we have r to be 2. Okay, and then the first number a means the first number, and then this is 2 over 3, and this one we have 1 over 5 to be first number, and the ratio is minus 1 over 5. Well, no matter what situation, so you will see the final answer and the general purpose is that we got this one. Okay, limit Sn exists if the ratio absolute value smaller than 1, so then we limit exists. Okay, so which means that we have to test for r. If r, the absolute sign, no matter it's positive or negative, is smaller than 0, so then the sum of sequence exists, which means convergent. Okay, if r absolute sign larger than 0, so the sum of sequence is divergent. Okay, sum of sequence exists converge. R absolute sign larger than 1, sum of the sequence is divergence. Just take a very short question, so say like maybe like 6 plus 12 plus 18 plus ... because we have 12 divided by 6 is the R 12 divided by 6, which is 2, and then this is larger than 1, so that's why the whole sequence is divergent according to the rules that I have just given to you, right? Okay, so another example is if we have like 1 plus 0.5 plus 0.25 plus 0.125 and then plus ... Okay, so we have the R, which is 0.5, the latest numbers divided by the previous numbers. So we've got 0.5. The absolute sign is smaller than 1. So I mean the ratio is smaller than 1. So that means this ratio is convergent. And that's it.